So before we move into example 2, let's make a quick note here that we can see in the box above. We should note that if our function of f actually takes on negative and positive values, that is, it takes on negative and positive y values, part of the graph exists above the x-axis and part of the graph exists below the x-axis, then rectangles that are above the x-axis would actually be regarded as having positive area, while rectangles that exist below the x-axis would be considered having negative area. To kind of get a sense of what we mean by this, let's take a look here at example 2. We're going to let A be the area of the region that lies between the x-axis and underneath this graph, specifically on the interval from -1 to 2. Now, if you were to go to a calculator or something, or try to graph this out by hand, you could easily start to see what this graph looks like. It's a fairly easy graph to actually work with by hand because, as you might be able to tell, you could factor out an x here, and you could easily find some zeros for this. You could find here that you're going to have a 0 at -2, at 0, and at +2. And the graph here is actually going to end up looking something like this on the given interval. Okay, it's going to look something like this. Of course, the graph would continue on. Now, we're only going to be interested in working from -1 over to 2. And so we're only going to be dealing with the space that's going to be positioned in here and down here. Notice this is the space that's between the function and the x-axis. Now, the area that's considered up here we would regard as positive area, whereas the area down here we're going to consider as negative area. Now, that's kind of strange because we normally never think about areas being negative, but we'll talk about why we actually consider this more in videos to come. So let's take a look here at how we would actually think about answering part A for this question. I want to estimate the area here by using a Riemann sum with left endpoints and 3 rectangles. Okay, so let's start by identifying our width. Our width, shown by delta x, should be given by the length of my interval. So notice here I'm going from 2 back to -1. So the total distance there is going to be 3. And I'm going to chop this up into 3 individual pieces. So each interval is going to have a length of 1. Let's try to draw them out. I'm going to have a rectangle that goes here from -1 to 0. And then I'm going to have a rectangle that goes from 0 to 1, and then from 1 to 2. Okay, so these are kind of the bases of each one of my rectangles. Now, let's go ahead and figure out the heights if we're going to be using a left endpoint. So notice here, if I'm using a left endpoint, I have to go all the way up till I hit the function, and then come all the way across. So I can see here I'm going to be drastically overestimating the area here. On this portion, I'm going to be going ahead and grabbing the left point and going and hitting the function, and I'm already there. So I I'm going to end up with a rectangle with no height. Over here, I'm going to start on the left side and go until I hit the function, which notice is going to require that I go down. Then I'll go over, and I'll end up with this. Again, kind of overestimating what I have there. So let's see what I end up with. For my total area here, I can approximate that by saying I'm going to have a width of 1 times, and then each of my heights in here. My heights are going to be given by f of -1, f of 0, and f of +1. Those are all my left-hand sides. So notice that this is just going to be, well, I guess just all these heights added together because times 1 doesn't change anything. So let's see, if I plug -1 here, I'm going to get -1 plus 4. So that's going to be a value of 3. We already see if I plug in 0, I get 0. And if I plug in the value of 1, I get 1 minus 4, which is going to be -3. And so overall, I get a final value of 0. Notice one important or two important things here. First off, the height of this final rectangle, this one over here, is actually given a negative height, right? I'm getting a negative height here because my function actually exists below the x-axis. So when I have my height here of -3 and my width of 1, my total area here is coming out -3, whereas this area was coming out as +3. And so these are canceling out, and it's leaving my total approximation of the area under the curve at 0, because I have some positive portion and some negative portion that are canceling out. Now again, you might be asking, Kyle, how in the world would we ever consider an area negative? And typically we would never consider area negative. Like if I'm going to go to, Home Depot or Menards and pick up some paint, I'm never going to say, oh, I have to cover, negative 10 square feet of wall, right? Like I don't need to ever use negative area in that context. That's just ridiculous. But keep in mind that we said that area here could represent, with certain questions, real-world quantities. Maybe it's something like the profit that a business earns over a given period of time. Well, maybe this means something like the company earned $3 million in this quarter. The company earned $0 profit in this quarter. And now the company lost $3 million. They didn't profit, but they lost an amount of money. Well, then I could ask, what's the total amount of profit that the company generated? Well, they broke even. And so I can actually see that when I think about other real-world quantities, negative amounts actually make perfect sense. In terms of distance, I could say I drove 3 miles to the east. I drove 0 miles. Then I drove negative 3 miles to the east, or like 3 miles to the west. And then I could ask how far left or right did I move? And well, I didn't move at all. So these quantities being negative and positive actually make perfect sense. So let's take a look here then at part B. Or actually, I'm going to ask you to take a look at part B and see if you can try to work through this example on your own. I want you to estimate the area under this same curve using right endpoints and 6 rectangles. Now, I'm not going to go ahead and work out the solution here fully, but I'm going to ask you to go ahead, pause the video right now, try to work through this, and then go check your solution up in the notes on Blackboard. When you unpause, I'll at least reveal what the final solution should have been. Okay, so hopefully you did go ahead and work through this particular problem. If you did check up online, you should have seen that our final answer ended up here as a negative quantity. It was negative 45 over 16, or as a decimal, that's negative 2.8125. So this would be our approximation of the area, and it kind of makes sense that we're ending with something that's negative, because it looks like we have more negative space here than positive space, more space below the x-axis than above the x-axis. So hopefully you're feeling pretty comfortable with using this idea of Riemann sums to estimate areas under curves.